Find the zeros. One of the most handy things to do when you're finding 0 is put a 0 in for f of x, because that's going to be the value. Oh, and this one should be an x. Function valued at x. Something crazy happened right there. Plus 5. We want to get to 14. I'm going to have to do this the long way. So I've got 8 times 5 is 40. We want to add up to negative 14. Again, this is factor by grouping. It's something I showed my class. Your teacher may not have shown it to you this way. If you do the universal method, it is pretty much the same process, but slightly different, of course. So right here, I'm going to factor out a 4x, and I'm going to get a 2x minus 5. Well, I'm going to factor out a 2x, rather, and get 2x minus 5. 4x minus 5. What am I doing here? 4x minus 5. And then factor out over here a negative 1 and get 4x minus 5. That will give me a final factor form of 2x minus 1, 4x minus 5, and it will give me my two answers of positive 1/2 and 5/4. Here, throw out the 0, take off your 2, divide everything by 2. We've got a perfect square minus perfect square, so I'll have x plus 4, x minus 4. And get my two answers. X is equal to positive 4, negative 4. You can list it as plus minus 4 if you want. I'm going to list it the long way. Again, 0 is equal to x squared plus 5x plus 6. Factor it out. 0 is equal to x plus 2, x plus 3. You'll get your two answers of x equal negative 2 from right here and negative 3 from right here. Our last one, 0 is equal to x squared minus 18x plus 32. So 32 go to 18, so 16 and 2. X squared, or x minus 16, x minus 2 equals 0. So from this point, you'll get x is equal to positive 16 and positive 2. Looking at 37, find the missing value. Again, this is one of those times, it's very, very easy. You just have to relax and do the problem. So notice they have factored this out. And they've got what looks like 6 and 15 are their two factors, and you just have to put in that factor, that missing factor. 38 is a long one. It's several perfect squares. M to the 8 and n to the 8 are both perfect squares. So we'll have m4 minus n4 and m4 plus n4. You'll factor this one out again to 2 and 2. And then, of course, your m4 plus m4 will stay. And then this, the m squared, n squared, factors out one more time to n minus n, m plus n. And then, of course, these two stay. So m squared plus n squared, and then m4 plus n4. It's a very long problem, but it's handy to know. Looking at number 39. Remember, when you list these sides, this is not 100 times x, it's 100 plus x. Just if I had 2 lengths of rope and one was 5 and one was 4, you would say right here, I've got 9 feet of rope. You wouldn't say 20, you would say 9, because you're adding them together. For the same reasons, you'll have 50 plus x and 100 plus x as your width and length. So write a polynomial that represents the combined area of the pool and the patio. 100 plus x, and then 50 plus x. This is equal to the area. We want the combined area to be 8,400. So I'm going to say 100 plus x times 50 plus x is equal to 8,400. At this point, I could FOIL it out. I'm going to get 5,000 plus 100x plus 50x plus x squared is equal to 8,400. Subtract the 8,400 to the other side, and I'm going to get x squared plus 150x minus 3,400 is equal to 0. Factors of negative 3,400 that add up to 150 are going to be positive 170 and negative 20. I'm going to get two answers. X equals negative 170 and x is equal to 20. Throw out the 170 because you don't want a negative length, and the patio should be 20 feet wide. That's this page. On to the final page.